Hello and welcome to Math 251 Calculus 1 here at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video, we will go over section 2.2, limits of functions. In this section, we will be introduced to some basic notation for finding limits of a function. And then we will give a rough definition of what a limit means. The idea behind a limit is we want to say that we're looking for the limit as x approaches a of a function f of x, and if we can find that limit, we will call it L, capital L. Now once we've established the idea of limits, we will find limits graphically. In this particular example, the first graph on the left here has a limit, even though the function is not defined at the particular point. The second function does not have a limit, because if you approach limit from one side and you approach the limit from the other side, you're going to get two different points. And then in our last example, we can say that the limit goes to positive infinity. In some cases, because it doesn't fall into one particular number, we might say that the limit doesn't exist. But in some cases, we might want to identify that it actually does go to positive infinity, and so we can actually get a picture of how the graph behaves. We will also be finding limits by creating tables. The idea is that if you want the limit as x approaches a, we can take a look at a and a bunch of numbers a little bit to the left of a getting closer and closer to a. Like the expression a minus 0.1 would be 0.1 units away from a minus 0.01 gets a little bit closer to a minus 0.001 gets even closer, etc. So when we're looking at a minus 0.0001, we're looking at how close it gets as we come from the left side. Now, coming from the other side, we're looking at values like a plus 0.1 or a plus 0.01. And then if we run through that and you get a plus 0.0001, then you're really close to a, but you're coming from the right side. And so we will be creating tables like this to see if we can find out if a particular function has a limit at a point. That talk about coming from the left side and coming from the right side has a notation as well. So the first notation on top here takes a look at the limit as x approaches a from the left side, the negative sign as an exponent of a, saying it's coming from the left. And then the limit as a coming from the right side, is the exponent is a plus sign. So if these two limits exist, then the limit as x approaches to a in general will exist. But if they are two different numbers or two different expressions or values, then we would say that the limit does not exist, even if these one-sided limits do exist. And speaking about limits going to infinity, we can also, if we define limits as going to infinity and not just actual finite numbers, then we can get a picture for the graph. In that first graph here, we can say that the limit as x approaches a from the left side will go to negative infinity, whereas the limit as x approaches a from the right side goes to positive infinity. In our second example here, we have the limit as x approaches a from the left side goes to positive infinity, and similarly the limit as x approaches a from the right side goes to positive infinity. So we can say that for this right graph, we can say that the limit as x approaches a of this function actually goes to positive infinity. Alright, this is our overview of section 2.2. Good luck.